in order to see where we have corrosion in this particular load case. Now we only added corrosion to the one load case. So if we come in, and if you want to see the corroded plate, we'll use the view thickness. Now we could use, view by ID to see what the plate properties are and so forth. But if we want to see the corrosion, we want to come in and look at plate thickness here. So we will tell it to color by the plate thickness. Now, most of our plating, and since we're in meters, it's a little difficult to see our scale here. So let's change the units over to millimeters. Make it a little easier to see this scale. We'll come back to view thickness for the plate. And we have basically 14 and 19 millimeter plate, which we already knew. If we come in with dynamic query, you can see we have 19 millimeter up there, and it tells you both the thickness and the net thickness. 14 millimeter. If we come over to our tank, which we know is corroded, we can query it, and it says thickness and net thickness is still 14. And that's because our current display is for plate thickness. If we want to see the corrosion, we come into thickness and we tell it with net corrosion or with percent corrosion. It depends how we defined our corrosion. We defined it with net, so we'll say with net corrosion. And now you can see we have some smaller plate here. The red is the 5 millimeter plate. And unfortunately, the beams, which are not being displayed, we're showing plate thickness here. The default color is red, so that's not actually for 5 millimeter, that's because it's a beam. But if we just view the plate here, red plate elements are 5 millimeter. And if we view this, we can see we've only got 5 millimeters left on our net thickness here. That was because in our tank, we said we only had a net remaining of 5 millimeters, and web and flange were 3. For our deck patch, again, we used 5, 3, and 3. We can modify that. Actually, let's modify that for the tank. And instead of net remaining, let's do net corroded with 5 millimeters, 3, and 3. So we'll modify them all. So now we have a net corroded instead of net remaining. And we will view plate and with corrosion net. When we come into dynamic query, you see our 14 millimeters got reduced by 5 down to 9 millimeter. And if we query one of these beams, while it's not being displayed visually, we can see the actual numbers. So our web thickness dropped from 11.9 to a net web thickness of 8.9. So we lost 3 millimeters. And again, for the flange thickness, 15.5 down to 12.5. So again, 3 millimeters. We can, instead of coloring by plate, we could view the beam web. And actually, it allows you to show both plate and either the beam web or the flange. It won't do beam web and flange at the same time. You have to pick one or the other. The plates and the beams can sort of toggle independent of one another for the coloring. Now, since we're viewing a beam thickness here, all of our quads and tris go to the default coloring of red, which unfortunately is actually a display color from the color bar. So it might be better to use these in gray or something where, when it's not applicable, it's strictly a graphics issue. And if we turn the plate coloring back on, which would normally be on, you can see the plates and now the beams are both colored appropriately. Because you can see we're coloring by flange thickness here, and our flange is 21.1 millimeters on that girder, which doesn't have any corrosion. So now that we've sort of done some of the dynamic queries with that, let's go back and look into this percentage of remaining thickness. So for the tank here, right now it's 100% of the remaining thickness. So let's take that down to 50% of the remaining. So we'll modify that. And turn on the plate coloring again. And now when we query it, we can see our plate thickness, which was originally 14, minus the 5 millimeters of corrosion, taking us down to 9, and now we only have 50% of that left. So if this passed with no apparent issues, we can kind of quickly add additional corrosion basically by reducing the remaining thickness to see how far we can go before we start seeing failures. Similarly, if we had seen failures with the 5 millimeters, we could have, instead of dropping it down to 50%, we could have started increasing it, which is essentially reducing the amount of corrosion. But the intent, I think, there was probably to say, what if our original scantlings were a little higher, 10% higher, and then minus that 5% of corrosion? This is what our result would be, without having to actually go through and modify all of your groups or your original scantlings, because changing your original scantlings will affect every load condition, not just this one.